Okay, I'm going to go through a basic data analysis example, and I'm going to do that using some stock price data that we will download from Google. You can see I'm using a Jupyter Notebook here, and if you want to get R in the Jupyter Notebook, you don't have it already, I have a short video for that you can find on my YouTube channel. So to get going here, what we need to do is we're going to use the QuantMod library to download our data. And if you don't already have it installed, all right, this is the code you will need to install it. All right, without the hashtag there, you will run that line of code, and you can run it in the Jupyter Notebook with Shift Enter, or you can click on the Run button up here in the toolbar. Okay, once you get it installed, we're going to go ahead and load the library. Okay, and with the library loaded, then we can go ahead and get some price data. I'm going to go get some price data for Tesla. All right, I'm going to use the QuantMod built-in function get symbols. All right, and all it really needs is the symbol. All right, but I'm going to go ahead and tell it to get the prices from Google. All right, and then I'm going to limit the data we get, so I'm going to set a from date, and I'll get about a year's worth of data here. Alright, and then I have to set this internal sort of bookkeeping function to false. You may not have to do this if they've updated the package by the time you install it. Alright, so I'm going to go ahead and get the data. Alright, and we should take a quick look at what we got. So I'll get the first few rows with the head function. Okay, and so you can see what we get, right? Data going back to 2016, and we get the open, low, high, close, and the volume. All right, all we really want though to do this example is the closing price. So I'm going to go ahead and set a new variable. All right, and I'm going to get out of the full data set, I'm going to get just the closing column. All right, and if you want, we can take a quick look at that. All right, so you see we just have the close. All right, and what we're interested in here is not necessarily the price, but the change in the price from close to close. So I'm going to do a quick transformation here of the closing price. All right, and I'm going to store it in a data frame. All right, and just so that R doesn't complain potentially later about numerical values, I'm going to store it as a matrix inside that data frame. All right, and what I'm going to do is calculate the log of the difference. All right. Okay, so the log of the difference will give us our instantaneous rate of return. All right, and we can take a look at what that looks like. Right, and so you can see that, yeah, for the first row we don't have one because there is no difference, for the 719 here. So we could either exclude that data, or we can let R worry about it. That's probably what I'll do. All right, but we can see that the change from the 20th to the 21st was Tesla went down 3.5%. And you can kind of see that here, right? So it was 220 on the close on the 21st. All right, down $8 from the previous day, about. Okay. All right. So once you get the data, you get it transformed the way you like it. You probably want to get a sense of some descriptives for that data. So there are many ways to get descriptive statistics out of R. I'm just going to use this built-in summary function to start with. All right, so we can get a quick hit on things, all right? It doesn't give you lots of stuff, all right, but it gives you some nice things, all right? So the min, the max, right? The mean and median, and then the first and third quartiles, all right? So just give you a basic hit on descriptives, right? Maybe you want more than it's giving. You certainly probably at least want the standard deviation. All right, and to do that, then we need to sort of dig a little deeper. And yeah, there are lots of packages that you can get descriptives out of a data set with. I'm going to use this psych module, or the psych library. All right, and it's lowercase. All right, and once I load that, then I can use its describe function, all right, to describe, all right, the Tesla change, all right. And if you don't sort of like looking at it like that, we can transpose it using the transpose function. All right, so we get more of a traditional tabular output. All right, so you can see that, oh, okay, we get a lot more stuff out of here. We don't get out of the box, at least, we don't get any of the percentiles, all right? But I left a note up here that lets you get whatever collection of quantiles or percentiles that you want using the quant parameter, all right, and then just sort of combining whatever you want into a little vector to get the percentiles you're interested in. All right, but what you do get is, of course, the standard deviation, very useful. All right, you get a trimmed mean, and by default, this is leaving off the top and bottom 10% of observations. You can set that to be whatever you want. You get the mean average deviation, a range, all right, and then you get the skewness and kurtosis. All right, so we can see a little bit negatively skewed, but basically the kurtosis pretty much associated with a normal. Okay, all right, and so once you have your descriptives, you can kind of look at it, you know what to expect to see. All right, the next step you probably want to do is get a visualization of the data, and there are a number of ways to do this. I'm just going to go ahead and use the built-in hist function, all right, and I'm going to get a histogram of the change, all right, and then I'm going to have to tell it to get all of the first column like that, okay, and so just like that, all right, we get a histogram, all right. Sorry that we can't see it all in one page here. I'm kind of zoomed in so you can see what I'm typing. All right, so that's kind of right out of the box, and yeah, you get a quick understanding of what the shape of that data is. Roughly normal, a little bit harder to see that negative skew that we were talking about, but it's sort of there. This is what R thinks we want to see. If we want to change it up a little bit, right, I can add some more bins in there. All right, so it came with 8. All right, probably we'll try to keep it around 8 or 10 bins. If you need more, right, we can just sort of tell it what to do. We can put a different label on the x-axis. All right, and then we can call it, I don't know, change. All right, we can give it the chart a better title than that. All right, that's the main parameter. Tesla price change. Okay, and then if we want to give it a color so it gives a little bit more visual appeal, right, I can just use one of these, one of the hundreds of colors you can find for R. All right, Alice blue is one of them. All right, it's just sort of a light blue. Okay, and okay, when I break it up into 25 bins, suddenly it's a little bit easier to sort of see that negative skew that we were talking about. All right, with most of the changes happening in here around 0. All right, and then probably these 4 here we have a year's worth of data, those are probably the 4 earning states, I would guess. And so, 3 bad ones, 1 good one, with everything else happening within plus or minus 5%. Okay. All right. I'll just show you one more histogram using the popular ggplot2 library. All right, and it's not quite as intuitive to use as the built-in R tool. Okay, with ggplot, you first have to obviously load the library. So if you don't have it, you would install it the same way as you would install the quant mod. All right, install packages ggplot2. All right, like I said, it's not quite as intuitive. You have to call the ggplot function. You have to give it some data. All right, all this stuff is sort of pretty flexible, but this is the basic way you do it, right? You call ggplot, you give it some data, and then you start adding layers to your graph. All right, so the function to do that is with the geom. All right, geometry, I guess, and this is going to be the histogram. Okay. And then, yeah, you have to give it an aesthetic, all right? So like I said, it's not quite as intuitive, right? You're not just going to kind of stumble on this, I guess, without reading the documents. So we'll get the close, and yeah, to get the color, right, I'll just use blue, it's fine. Basically, we get about the same thing, all right, as we got the second time around with the built-in tool. All right, so here it's telling you that, oh, it's using 30 bins. So if you want to change that, right, you can either set a bin width, or you can choose a different number of bins. It's telling you that it removed that NA value. All right, so this graph also removed it, but it just didn't tell us that, right? So you have to kind of sometimes pay attention to that with R. It will remove invalid data just so that you get some kind of graph out there, or it may do it for a calculation too. Here, ggplot has nicely told us that it took off that NA as the first row. Okay. All right, but this is sort of the basically out of the box ggplot graph that we got. All right, so 30 bins, right? We can see that negative skewness. All right, and it's sort of labeled nicely. Again, we could change the title and the axis labels and do any number of things that we want to this graph. All right. Okay, I'm going to show you one more ggplot. All right, and we're going to start the same way. All right, and right, we call ggplot. We're going to call this geom, in this case density plot, which will give us a smooth, basically a smooth plot that's very related to the histogram. All right. With it, I guess you can calculate a little bit more exactly probabilities of a certain price change occurring. Okay. Okay, so we're basically do the same thing, except, right, we're calling the density function instead of the histogram function. Okay, again, it tells us it took out that one bad value. All right, and then I'll get this on the screen as best I can. We can kind of see a smoothed representation of the data that gives us sort of a different perspective, I guess, than a histogram does. Okay, so I hope that helps with R and describing data.